Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll be learning the third subtopic of this chapter 1, okay? So today we'll be learning on how to investigate and make generalization about the effects of changing the values of a, b, and c on graphs of quadratic functions fx equals to ax squared plus bx plus c, okay? So we know that the value of a determines the shape of the graph, okay? As what we have learned previously, if a is greater than 0, it will be a smiley. If a is less than 0, it will be an inverted smiley, okay? So if you don't know what is the value of a, if you don't know how to identify the value of a, you can refer to my previous video, okay? So let us read this, okay? This is important. For the graph of a quadratic function fx equals to ax squared plus bx plus c, the smaller the value of a, the wider is the curved shape of the graph. Let us just refer to these two graphs fx and gx, okay? So according to what we have learned here, the smaller the value of a, the wider the curved shape. So we know that a1 is actually less than a2 because a1 is wider, okay? Let us check and see. Yeah, okay, so correct. So let us look at this graph. The smaller the value of a, the wider the curved shape. So in this case, it is an inverted smiley, okay? So we know that a is less than 0 for a1 and a2 in this case, okay? So we can see that fx equals to negative a1 x squared is wider, okay? So let us ignore the negative sign first, okay? The smaller the value of a, the wider the curved shape. So we know that a1 is less than a2, okay? Let us check and see whether it is correct. Okay, so this is correct also. So now I hope you already understand what is the effect of value of a on determine the shape of graph, okay? So this mind stimulation 8, you guys can do it at home, okay? And then from this activity, you will know the value of b determines the position of the axis of symmetry, okay? Whenever b changes, the axis of symmetry will change, okay? So again, let us refer to this. This is important, okay? For the graph of a quadratic function, fx equals to ax squared plus bx plus c, if a is greater than 0, it is a smiley, okay? If a is greater than 0 and b is greater than 0, the axis of symmetry lies on the left of the y-axis. If a is positive but b is negative, the axis of symmetry will be on the right of the y-axis. And if b equals to 0, the axis of symmetry will be the y-axis itself, okay? So we can refer to here. And then for the case of a is less than 0, we know that it is an inverted smiley, okay? So again, if a is negative, b is positive, the axis of symmetry will be on the right hand side of the y-axis, okay? And then if a is negative, b is negative, the axis of symmetry will be on the left of the y-axis, okay? If b is equals to 0, the axis of symmetry is the y-axis, okay? So what we can conclude from here is that if a and b are having the same sign, okay, either both greater than 0 or both less than 0, then the axis of symmetry will be on the left hand side of the y-axis. But whenever they are having different signs, let's say a greater than 0, b less than 0, or a less than 0, b greater than 0, the axis of symmetry will be on the right hand side of the y-axis, okay? So whenever b is equals to 0, the axis of symmetry will be the y-axis itself, okay? Then this mind stimulation 9, again, you guys will be doing it at home. And what we can learn from this mind stimulation 9 is that the value of c is actually the y-intercept, okay? So let us read this. For the graph of a quadratic function f(x) equals to ax squared plus bx plus c, the value of c determines the y-intercept, okay? So this graph is an inverted smiley, a is less than 0. This graph is a smiley, so a is greater than 0. And this is the y-intercept, okay? Y-intercept is the place where the graph cuts the y-axis, okay? So let's go through this example 2 together. The quadratic function f(x) equals to x squared minus 3x plus c passes through a point A as given below. Calculate the value of c. So we can see that this point is a point on this graph, okay? And the x coordinate is actually equals to 0. So we know that this point A is the y-intercept. So in this case, without any calculation, we know that c is equals to 4. Okay? Then for B, this case we will have to do the calculation, okay? We'll substitute this -1 into x, and then we'll substitute this 3 as a value of f(x), okay? So 3 is equals to -1 squared minus 3 times -1 plus c, okay? Which is equals to 1 plus 3 plus c, okay? So we know that c equals to -1 as shown here, okay? Because we know that this is a point on the graph, so we can substitute it into the function, okay? So now let us proceed to example 3. The diagram shows two graphs of quadratic functions, y equals to f(x) and y equals to gx, drawn on the same axis. State the range of the values of p. So we can see that both f(x) and gx are smiley, so we know that p is greater than 0, okay? And we can see that f(x) equals to 3x squared minus 4 is narrower compared to gx, okay? So we know that p is actually less than 3 because gx is a wider graph in this case, okay? So we know that the range of p is p less than 3 and greater than 0, okay? As shown here. So this self-practice 1.1c, you guys will be doing it at home so that you can understand better what we have learned just now, okay? So if you are having a lot of difficulties in completing your self-practices in the textbook, I have prepared an online course for you guys so that it can help you guys in completing your homework at home, okay? So do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos, okay? So coming next, we'll be learning on how to form a quadratic equation based on a situation, okay? So see you in the next video. Bye bye.